Okay, so our question is, the continuous random variable has probability density function f of x, where f of x is k times x plus 2 squared over the range minus 2 less than x less than or equal to 0, and then function 4k for 0 less than or equal to x less than or equal to 4/3. So before we start, it's worth mentioning that nothing really changes that much here, because when we integrated with one function with probability density function, what we know is if we integrate it over the range, then full range, it will give us a total probability of 1. What happens here is we have two functions, so what we're going to do is we're going to sum the values of integrating those two functions over the two ranges. So I'm just using f of x to speed things up and save a little space here, but what we're doing is we're just going to integrate the function between minus 2 and 0, and then we're going to integrate the function between 0 and 4/3, and when we total this up, this is still equal to 1, so nothing's changed there. Okay, so yes, it's a little bit more tricky, yes, it's a little bit more laborious, but the process is the same. Now before we start, we're going to need to expand the bracket x plus 2 squared so that we've got a function that we are able to integrate. So just remember, please, no silly mistakes, no shortcuts. Just remember that this means, of course, the bracket x plus 2 multiplied by itself. Don't just square the x term, because of course we do get x squared, but then we get two lots of 2x when we expand it, and then we get the 2 squared, which is 4. Okay, so I'm going to integrate it over that range now, minus 2 to 0. One second, before I do that, actually I want to take the k outside. The reason I take the k outside is it won't interfere with everything, it'll just simplify all the work that I'm doing when I evaluate the integral. I can just get a numerical value for the integral and then multiply it by the k. So let's integrate x squared plus 4x plus 4. Oops. Okay. And see what happens. So remembering the k outside the front, x squared becomes x cubed over 3 plus, now x becomes x squared. A little bit of forward planning here, thinking about what happens. So that coefficient there, I'm going to divide it by the new power 2, and so 4 divided by 2 gives me 2x squared, and I can just simplify it straight away in that step, save a little bit of time. Plus 4x, and this is over the range minus 2 to 0. Now lots of people make the careless mistake when we do this of just assuming that when we put 0 into this function, it's going to be equal to 0. And a lot of the time, certainly at AS, that's true. But it's important that we don't build up bad habits, because this will change when you get to A2. And of course, you're going to see here, if you just take it as equal to 0, you may make a little mistake. And I'll show you where you may make a little mistake in a second. So it's better practice just to put it in. I know it's a little bit of extra writing, but we know it's going to evaluate to 0 in the end. You can just put it in 0 on your calculator in a second when we do it. It's all about this negative here. Okay, so it's just making sure that we've got that negative in, because what happens is if we evaluate this as 0 and we just ignore it, some people tend to ignore and forget that there's a minus here. Okay, of course this shouldn't be x cubed, sorry. Let's just get a rubber. Apologies, give me a second. There we go. This should, of course, be minus 2 cubed. Let's just get back to pencils. So, minus 2 cubed over 3 plus 2 lots of minus 2 squared plus 4 lots of minus 2. Okay, so when I close that up and I put the square bracket around it, I can use my calculator to evaluate this in one go. First bit here, that's going to be equal to 0. I then get 8 plus 8 take away 8, so I get minus 8/3 here, and when I do the minus minus, I get plus 8/3, so I get 8/3, and of course you can use your calculator to check that. If you just tidy this up a little bit, it's going to become 8k over 3, and that's the first integral. Okay, now usually what we do if we had one function, we'd put this equal to 1 and we'd solve it and we'd find a value. But now what we're going to have to do is we're going to have to integrate the second function over the range 0 to 4/3. So I'm going to go take the k outside the front again, 0 to 4/3. We've just got 4 dx. So when I integrate this, nice and straightforward actually, this one. 4 integrates to 4x. So this is integrated over the range 0 and 4/3. And so k outside, we are going to get 4 lots of 4/3 minus 4 lots of 0. No need for the brackets here because I've just got the one term. I can just evaluate those one terms as they are. So what happens here, obviously again I get 0 here, but good practice making sure that I write it in. 4 times 4/3, we tie this up, it's going to be 16/3, so I can get 16k over 3. So all the hard work's done at this point. I found out what the integral is equal to over the range -2 to 0. I found out what that integral is equal to over the range 0 to 4/3. Now I'm going to sum them together and put it equal to 1. So we've got 8k over 3 plus 16k over 3, and this is equal to 1. So running along my line, so just using that arrow to indicate I'm coming across the line, clearly making sure it's not an equal sign. I've got 24k over 3 equal to 1. What I'm going to do here is I'm going to times by 3, and then I'm going to divide by 24 to get this k on its own. And what that leads to in that case is when 1 is multiplied by 3, I get 3. When it's divided by 24, essentially we get in the fraction inverted. And there we have it. K is equal to 3 over 24. So what have we learnt here? Well, we've learnt that we're just applying exactly the same principle as we do for a continuous random variable when we have one PDF, where we integrate it over that full range and equate it to be equal to 1. We're doing exactly the same here with 2 functions, and in fact you can extend this if you had a probability density function defined over 3 functions or even 4 functions, although this isn't something that you're necessarily going to have to deal with. Okay, hope that made sense.